Welcome back to my channel. Carly said she didn't want to do it, so I did it for her. Today, we are going to start talking about angles. We've been talking about angles in terms of a triangle, like angles of elevation and depression. We've been talking about 90-degree angles for what seems like a million years now. But today, we're talking about angles on a coordinate plane. So that's just these guys where you have an X and a Y. You've seen it a bunch. You've seen a coordinate plane a bunch. So we're going to start with angles of rotation. This is page 112. This is page 112. Guess I better get there as well. An angle is in standard position when its vertex is at the blank and its initial side lies on the blank. Oh no. I think that's when the vertex is at the origin. Don't write that in until I double check. And the initial side lies on the x-axis. Let's see if I'm right. Yep. So, an angle is in standard position when its vertex is at the origin. So that's 0, 0. And its initial side lies on the positive x-axis. Phone down. Okay, cool. Got it. So, positive x-axis is this side of the x-axis. That's what they mean by positive x-axis. Because on this side, it's negative. And we know that because this point right here is the origin, or 0, 0. So points to the left are negative, points up are positive, points down are negative. You're hanging in? So standard position is the vertex is here, the initial side is the positive x-axis, and then your angle opens up to the left, counterclockwise. So this is reminding you of what these degrees are. Right here, this is 0 degrees. In the middle, right in the middle of these two, 45 degrees. Then up is 90 degrees. It makes that little corner, that square. So this is halfway between 90 and 180. What is that? 135? I think that's 135. And then a straight line is 180. Straight line is 180. Then in between here, we just add 45 degrees to 180. So that's 225. Then 270, and this one would be 270 plus 45. So what's that, 315? Cool. So each one of these little sections we just wrote down was 45 degrees. So 45, and then add 45, you get 90. Add 45, you get 135, 180, 225, 270, 315, 360. Does this sound vaguely familiar? A little bit? Maybe a smidge? Okay. Counterclockwise rotations are positive. So that's this way. If the angle's going that way, it's positive. Clockwise rotations are negative. So that's if they're going that way. And the terminal side, which I'll make more clear once we actually graph one of these, it can rotate more than 360. So you can have an angle that's more than a full circle. You just keep going and make like a spiral. Okay, so for all of these, it says our angle is in standard position, which means that one leg is always this part of the graph. This is our initial side. So we need an angle that's positive 240. So I'm going to sneak back up to this guy and see my situation. Okay, so he's all the way in the third quadrant. So he's down here in the bottom left. And he's more than halfway between those. So he's probably like somewhere in here. So I'm going to start here. And I'm going to open up and come, I don't know, maybe right there. Because this is 270. So I think it's reasonable this guy is 240. Are you guys okay with that? Yes, no? Are you sure? Okay. This guy is the terminal side. It sounds like he's dying. It's a little sad. I'm just highlighting him a different color. This guy is the terminal side. So this is your initial side. This is your terminal side, the orange one. Okay. This is my angle. I got a big old ginormous angle. Probably be good if I put an arrow on it. Okay, not too bad. You guys are okay? Okay. Now the next one wants us to be drawn a negative angle. So that means we're going to go down. We're going to go clockwise. Well, I know that this is 0 degrees. And this is now negative 90 degrees. Halfway would be negative 45 degrees. Because 45 is halfway between 0 and 90. So if I need a 50-degree angle, I'm just going to come like really close to this 45-degree line. And then I'm going to kind of move him out of the way so that he doesn't confuse me. I'll put him right there. So this is now my terminal side. And I'm going to show which way I opened him. I opened clockwise. Make sure you get the negative on your angle. So this angle is opening up, going counterclockwise. This guy's opening down, going clockwise. Do you guys want to try 65 degrees? Yes. So remember, this guy is 0 degrees. This guy is 90 degrees. So 65 is going to be somewhere in this area. You decide where. Doesn't gotta be perfect. It's just gotta be almost perfect. Hi, kid. $30 is enough? Yes. About 30. Oh, I love how many of your Chromebooks are open. That's excellent because we're going to need Desmos in a minute. About 10. 5, 4, 3, 2, 1. Hopefully you're right. Okay, mine's right here. He's like a little bit past 45. Did you do okay? Yeah. Okay, the next one's the coolest because it's a spiral. He's 500 degrees. Holy moly. So, our terminal side is still here. Now, if we go all the way around once, so we make a full circle, that's 360 degrees. So the 360 degree line is at the same spot as the 0 degree line. And we know the difference because of whatever we have drawn here. So that means that in order to find this, he's not 90 anymore. He'd be 360 plus 90, which is 450, I believe. So that was 360 plus 90. So a full circle plus 90 degrees. Then if I do the same here, this one is 540 degrees because I do 360, just kidding. I do 450 plus 90. So that means 500 is like somewhere between these two. Maybe almost halfway between. So halfway, I would add 45 to get halfway. And that puts you at 495. So a 500 degree angle is like that guy right there. And that would be my terminal side. Then I would just finish up my spiral. So I ended it because I knew that I was going to have to keep going. And I wanted it to be clear that I was going so it can't look exactly like a perfect. Okay, teacher, get a grip. Okay, there's my spiral. So I'm going to have to move that guy out of the way. He's like cramping my style. Oh, dang. Did you get your little spiral in there? Yeah? Do you feel okay about it? Are you sure? Yes? Yeah. Okay. Now, Famil. The next one is 3 pi over 4. What? How come we're going degree, 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 degree? What? Fraction? Gross. So, we're gonna figure out how we can graph this and still use degrees. Because I feel really good about this degree situation. I mean, I don't love it, but I feel okay about it. So, we're going to talk about how we make that look like a degree and that look like a degree. So, we're going to skip coterminal angles. And we're going to go one more page to degrees versus radians. Turns out that angles can also be measured in radians. So it's just like how you can measure a length with centimeters or inches. So we're measuring the same thing, we're just using different units. Measuring same thing using different units. The radian measure of an angle is the measure of the arc length on a circle of radius 1. Holy moly. So this blank is length. So what they're saying over here is that we have a circle and its distance from the center is 1. That's what they mean by radius 1. What the radian measures is the length of the arc that the angle makes. So notice down here, this is the degree. This looks like a 50-degree angle. Out here is this like section of circle. So think about it as a slice of pizza. And a radian is the crust. It's the length of the crust. Does that make sense? Are you sure? Yeah. You're sure? Yes. Great. Great. So the angle, the degree is inside. The radian is the crust of the pizza. So it's the same thing, we're just using different units of measure. Okay, so let's figure out what these degrees are in radians. So 0 degrees is the same thing as 0 radians. So we're just going to write 0. Sometimes radian is abbreviated RAD, 0 rad. Okay, it turns out that there's a very easy formula to convert a degree to a radian. So in science, when you're converting things, you usually multiply it by a conversion factor, which is a fraction. And hopefully it sounds vaguely familiar that whatever we're trying to get rid of is in the bottom. Whatever we're trying to get rid of is in the bottom. So I have a degree in my bottom. Well, we're going to base this off of 180. And the conversion factor is that a 180-degree angle is equal to pi radians. So over here where you see 180 degrees, it's written in very lightly, but there is a pi there. So pi is the same thing as a 180-degree angle. So what we would plug into Desmos is 45 over 180. So I'm going to extend this fraction line, and now I'm going to go over to Desmos. I'm going to click on my calculator. I wonder what would happen if I put the pi in. So 45 pi, because pi is just one of my buttons, over 180. Look, it won't let me change it back. Okay, so take the pi out. That ain't a good idea. And what I meant by change it back is, now I have the option to make this a fraction. So what I have really in the top is 1 pi, and in the bottom 4. So in the top, my top went to 1, my bottom went to 4, but we can't forget we have that pi hanging out in there. So here at 45 degrees, what we're going to plug in is pi over 4. If it's 1 pi, it looks better for us to just write it as pi. Are you guys okay? Okay, now we do the same exact thing for 90. We do 90 degrees times pi over 180. The degree symbols go away, and what I type into Desmos is 90 backslash 180, hit the fraction button, and that gives you the top and the bottom. So 1 pi over 2. So that means 90 degrees is the same thing as pi over 2. Okay, I'm all right with that. So now we got to do 135. Same drill. 135 degrees times pi over 180. Degrees go away. I go over here. I do 135 backslash 180. Switch it back. So this one is 3 pi over 4. Okay, now you guys do the last 4. 225, 270, 315, 360. So essentially, you're plugging in 225 over 180, 270 over 180, 315 over 180, and then remembering to put pi in the numerator. So roughly 30. $20. $10. Okay, 180 is pi. Maybe I'll darken him up because he doesn't look good. Okay, 225, what's in my numerator? 5 pi over 4. Okay. 3 pi over 2. This next one, 7 pi? 7 pi over 4. And then this one is 2 pi. So all the way around is 2 pi. So degrees go from 0 to 360. Radians go from 0 to 2 pi. I feel okay about that. You guys feel kind of okay about that? So these are our conversion factors. If you start with a degree, you can change it to radians by doing what we just did. If you start with radians, you can change it by doing something very similar. You just switch the degree and the pi. So 395, we would just do times pi over 180. In Desmos, we would just plug in 395 over 180, and then you would have to convert to change it back to a fraction. So 395 over 180. That one did not come out nice for me. Did it come out nice for you? Oh, yeah. So 79 pi over 36. That one does not look nice. Okay, if you were entering this into Canvas, it's going to give you a spot for the numerator and denominator. So you would type in 79 pi. I don't put a space, but you can put a space. and then in the bottom, you would put 36. So in Canvas, it'll say numerator, denominator. Instead of entering in pi, the symbol, you can just type pi. Okay, next up, now this is the first one where we're going the other way. So I have to have what I'm trying to get rid of in the bottom. So pi has to be in the bottom, which means I have to move 180 to the top. The pi's will cancel out. And what I will type into Desmos, and I'm not expecting you to write this down every time, is 5 times 180 over 3. So I just type it in exactly like that. I hit the backslash, do 5 times 180, arrow down, do 3. So I'll do mine really quick. It's easier if you hit the backslash first. 5. Where's my times button? Wow. And I'm getting 300 degrees. Is that what you guys got? Okay. Okay. So negative 345, this is our first one with a negative. So I am going to do negative 345 degrees times, well, degree has to be in the bottom, so that means 180 will be in the bottom, pi will be in the top. When I go to write my answer for this for Canvas, I'm going to put my negative in the numerator. So I'm going to have negative 345 over 180. So negative 23 pi over 12. Negative 23 pi over 12. So in Canvas, I would type in negative 23 pi and then 12. You guys are doing 60 degrees? Negative 60 degrees? Okay, you guys try negative 60 and then we'll do 5 together. Got about 20. $10. $3. So in Canvas, I would put negative pi and then 3. I'm getting negative pi over 3. Is that what you guys got? Yes? Okay, let's do 5 together. So 35 pi over 18. I'm trying to get rid of the pi, which means that's what I have to put in the bottom. Because once I put it in the bottom, those two will cancel out. What goes in the top? 180. So in Desmos, I'm typing in backslash 35 times 180 over 18. I'm pretty sure that's 350 degrees. In Canvas, the degree symbol is already there, so you don't have to worry about putting it in. Okay, let's have you guys try 4 pi over 3 without me, just to verify. go about 15. $10. I got 240. So you guys got? Okay. So we can skip 7 and 8. If you did them, great. If you didn't, that's okay. And let's go back one page to revisit why we came to degrees versus radian. Remember, we're measuring the same thing. It's just like measuring in feet instead of measuring in meters. So I wanted us to be able to graph these two angles. So I would rather just graph in degrees, even though I know that this is 0 and this is pi. I still feel like degrees is easier for me. So if I'm getting rid of pi, I have to put it in the bottom. I have to put 180 in the top. Those will cancel. And in decimals, I'll put 3 times 180. And then I can divide that by 4. And I'm getting 135 degrees. Did anybody else get that? Okay, so just to remind myself, I know that this is 90. I know that this is 180. So 135 is actually one of the easier angles. It's in between 90 and 180, exactly in between them. So this is 3 pi over 4. Remember that our angle opens counterclockwise. So that's 3 pi over 4. So you guys try number 6 without me. So he's negative, make sure that you go the other way. Let's go 30. Roughly 10. Five. Okay, mine is going down and it's a little bit closer to the y-axis than it is to the x-axis. How'd you guys do? Did you do okay? Great. So your quiz is only on the converting. None of this angle stuff, just on the converting. I double checked the key, so I'm pretty sure that the key also is good. So yeah, okay. I'll publish it and you guys will give it a try.